In this video, we're going to answer the question of when do we use the limit definition of the derivative. So you might have seen this definition already. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And that gives you the derivative of f of x. Okay? It's a limit definition. So there's a lot of different functions out there, right? We have polynomials that look like this, x to the fifth plus 10x squared plus 2. We have exponential functions like e to the x. We have trig functions like sine x. And we have logarithmic functions like the natural log of x. So you might think, do I have to use the limit definition of the derivative to find all these different derivatives? So what is f prime of x for this polynomial? What is f prime of x for this log? And we actually don't use the limit definition of the derivative for all these different types of functions. People in the past hundreds of years have done that and have figured out easier ways to take these derivatives. And what we have to do is you'll have to memorize derivative rules. Memorize derivative rules. We're going to look at an example of a couple of the first derivative rules that you might learn. These make it really easy to find derivatives. You won't have to mess around with this tricky limit, really. And so when do we use the limit definition of the derivative? Almost never. Almost never. It's good to learn at the beginning of calculus so that you understand where the derivative comes from. And it applies limits, which is one of the first things that students learn in calc. So let's look at an example first of solving a derivative problem by using the limit, just for extra practice. We're going to do that on the left side, and then on the right side we're going to learn some of the first derivative rules, and we're going to see a different way of solving the same problem, an easier way. So first, we'll use the limit definition. We have f of x equals 3x squared plus x plus 5. And we're asking what is f prime of x. Okay, so let's remember the limit definition. F prime of x equals the limit as h approaches 0. F of x plus h minus f of x divided by h. Okay, so f prime of x equals the limit as h approaches 0. F of x plus h. Okay, that's going to be 3 times x plus h squared plus x plus h plus 5 minus f of x, 3x squared plus x plus 5. Okay, that's all divided by h. Now we have to do some algebra. Okay, this is going to be 3x squared plus 6xh plus 3h squared. Then we have plus x plus h plus 5. That's unchanged. We have minus 3x squared minus x minus 5. Remember to distribute the minus sign to all of these terms. Okay? Now we have some good cancellations. Plus 5 minus 5, plus x minus x, 3x squared minus 3x squared. And this is all divided by h. So what are we left with? The limit as h goes to 0. All of these terms left have an h in them, so I'm going to take one out, take away an h from that. I'm left with 6x. Take an h from this, 3h. And then take an h from h. I'm just left with 1. Divided by h. H's cancel. So this equals the limit as h approaches 0 of 6x plus 3h plus 1. Okay? This term does not have an h. This term does not have an h. This term has an h. And if h is approaching 0, that term is going away. So what are we left with? We're left with 6x plus 1. Okay? So f prime of x is equal to 6x plus 1. And that's using the limit definition of the derivative. So now let's take a look at some derivative rules. The first rule we're going to learn is if f of x is equal to c, where c is some number, like 5 or 10, that means that f prime of x is equal to 0. Okay? And that makes sense if you think about a graph. If f of x is equal to c, where c maybe is 5, let's say. It's just a line, right? What's the slope of this line everywhere? The slope of this line everywhere is 0. Okay? So if f is a constant, its derivative is 0. That's the first rule. Second rule we're going to learn is if f of x is equal to some constant a times y of x, another function, then f prime of x is equal to a times y prime of x. So what this rule is essentially saying is that constants don't affect derivatives. Notice that nothing happens to a as we take that derivative, right? A stays the same. What changes is y, right? And the third rule, if f of x is equal to x to the n, then f prime of x, the n drops down to be next to the x, so n drops down, and then we subtract 1 from n. And remember, this is just a rule. This is just something that we follow. Okay, so the n, you can think it just drops right down. Now let's apply these rules to this problem. Remember, we had f of x is 3x squared plus x plus 5. Okay? Let's start with 5. Let's go one by one and take derivatives of these individual functions. So if we have a function equal to 5, that means we're using this rule. The derivative of a constant is equal to 0. So the derivative of 5 is equal to 0. Now, on each of these lines, remember, we're taking the derivative. Okay? How about x? Well, x is equal to x to the 1. You can think about it that way. Right? So we're going to use this rule. Imagine n is equal to 1. So the 1 will drop down. We're going to have 1 times x, and then we have n minus 1, x to the 1 minus 1. That's 1x to the 0. X to the 0 is equal to 1. 1 times 1 is equal to 1. Okay? That's a little confusing at first, but that means that the derivative of x is equal to 1. And that makes sense, right? If we have the function y equals x, that would look something like this. The line through 0. It's a 45-degree angle, so the rise over the run is equal to 1. The slope of y equals x is 1, right? And for this last one, we're going to combine two of the rules. First, we see that we have some number, right, multiplied by another function. So what that means, we're going to take that number and nothing happens to it. We're just going to leave it to the left. Okay? Remember up here we had a times a function. That was equal to a times that function's derivative. So we're going to have 3 times the derivative of x squared. Well, what is the derivative of x squared? Okay? Let's take a look. I'll do it over here. X squared. That's one of these, right? X to the n. That 2 is going to come down. We're going to have 2 times x. And then we take 1 away from 2. So that's 2x to the 1. That's 2 times x, right? So 3 times 2x, and that's f prime, right? So now we have all the individual derivatives. We just add them up. 3 times 2x is 6x, plus 1, plus 0. Okay? That means that f prime of x is equal to 6x plus 1. Alright? And that's good because this matches what we got earlier. Right? Same answer, 2 different methods. This might look like it took the same amount of work as before, but once you know these rules, taking derivatives gets pretty easy for polynomials, right? These are all polynomial rules. We don't see any sine of x, we don't see any e to the x, but we have to start somewhere, and these polynomial rules are the easiest place to start, okay?